Semiconductors are fascinating, and I'm sure that there is no question about the core vitality of the semiconductors at the central stage of our global trade. In the last 2 decades, semiconductors have gone from 11th to 3rd place as the economic viability focus, leaving behind only the digital software industry as well as the pharma and biotech. This is basically phenomenal, and I'm going to touch base on this one in a bit. Our global demand for the semiconductor is soaring with the new architectural demands, and whosoever is working in either in the design part or on the fabrication side or even in the OEM part is actually aware of the fact that AI actually has driven it to the level which is unprecedented in the history of modern science. Anything to do with electric vehicles, Industry 4.0 and beyond, even the immersive technologies is revolving around the hardware demand, which is focused on semiconductors. A major established hub for high reliability manufacturing and backend, and lately they have also started a big investment in design side. China is a very interesting case because China was not really having a lot of nurturing in the open domain. They had been a local venturing, their own huge market value chain, but they're definitely now opening up to a more rigorous semiconductor ecosystem because of the fact that this is also a geopolitical arena. Europe is also trying to regain its weight in an increasingly support and consolidated ecosystem which is developed by European Act 2.0. So where we can basically get most of the chips manufactured, and this number is pretty known to everybody who is working in this area, but very interesting point is about 8% for the America. Now this basically had been a point since 2019 onwards, a national debate discourse for US semiconductor agencies, why America is only bending upon the IDMs and those fabs which are not located within the US territory. And this is basically the geopolitical arena which is triggering the whole debate in terms of the geopolitical arena of the semiconductor industry. And if you just basically have a look at the greater China part, so combined Hong Kong, China and Taiwan, looking a perspective of a territorial concentration of the greater China is a very demanding, a very challenging and a very robust factor within the production of the semiconductor chips. So this actually takes me to the point why strategically it is important to talk about semiconductors right now. Geopolitics has put silicon at the center of the struggle between the great powers. And this has been ongoing for a while. This has been unprecedented in the last 3 years. In 2022, we have US Chip Science Act, the famous resolution passed by the US Senate, and it's a huge and phenomenal funding which is basically poured into not many segments. For example, over a period of 8 to 10 years, it's $280 billion US, and which is spread for the chip makers, for the National Science Foundation in the US, the tax credits for the chip makers, the tech R&D, which is basically another phenomenal part of the whole discussion, and the energy department. But what my concern towards this particular slide is for all of us to ponder what National Science Foundation is concentrating on. So National Science Foundation has already got about 3 years of the funding out of this big chunk that they are getting into 81 billion to the US, and they are concentrating on these areas, which are basically depicted over here. And I'm only going to highlight advanced manufacturing, artificial materials, cyber infrastructure and advanced computing, and semiconductors, microelectronics, together with quantum information systems. So it is not just one shade of the semiconductor debate, it's a multidisciplinary approach towards this Chip Science Act proliferation. What European Union is doing is even a greater discussion. So it is in response to what US Chip Act said, EU Chip Act 2021, and then Act 2.0, which is just about to be materialized in 2026, they are catalyzing more than 80 billion euro in public and private investment to strengthen the chip manufacturing arena within the European Union. And their highest focus within this amount is to get the competency centers evolved. This is where our focus also needs to be drawn, where the European Chip Act is spending most parts of the funding to the skills initiatives and the competency centers developed across Europe. So the greater part of European Union Act 2.0 is focused not on the conventional nodes, but to the existing capacity building. So for example, power semiconductors, which had been their approach of the things in Ireland, in France, in some parts of the UK, in Greece, they are actually spending a lot of money to regain their weight in power semiconductors, integrated photonics, so the silicon light compendium, the advanced packaging and heterogeneous packaging part, and OSAT capabilities, and a little proportion is also going on to renewed focus on design and IP codes. So which actually takes us to a picture which is emerging out of this discussion, that this is also not just a value chain thing, it is also an international political friction on silicon and beyond. So for example, South Korea, which is a phenomenal stakeholder within this whole semiconductor ecosystem arena, is facing the mounting pressure from US AI chip tariffs. 25% tariff on advanced chips that are imported into the US and then re-exported to third countries. So TSMC, for example, is feeling the heat, and that's why they posed their own strategic alliance with some other companies and some European partners lately with a phenomenal $56 billion of their own initiatives on the semiconductor ecosystem. This provides you with an insight, and this is very latest, November 2025. This strategic geopolitical investment is being drawn almost in every part of semiconductor industry, wherever they are in the world. In every nook and corner wherever semiconductors are either designed or manufactured, or there are IDMs or there are OEMs, the support system for the semiconductor, they're basically pouring in a lot of funding and new revenues to be generated out of these consumptions just to basically have one particular native, and that is what having a foreign dependency localized. So this is basically the theme of the geopolitical arena for semiconductor and microchip industry going all around. So what exactly other countries are doing is as you can see from this particular ingredient, it is very important to understand that the United States has actually, with the Chip and Science Act, the European Union is going with European Act 2.0, but interesting part is not US and or European Union, it's the India concern, it's the Japan concern, and it's the Vietnam concern. So for example, Vietnam is rising as an Apple and Samsung assembly alternative. Now this is basically also supported to some extent by the US counterparts, but their own local domain is a very lucrative tax evasions and some policy orientations towards the semiconductor alignment in these areas. Another interesting story in this bit is Mexico, which is leveraging its proximity to the US, expanding its semiconductor manufacturing capabilities, and launched a national chip design hub to foster a homegrown chip element. And then again, it's basically something which is more important to realize that with the onset of a lot of different support systems from US, Israel is also known for advanced R&D, and they have puffed up a fair share of about 6% into the US Chip Science Act, directly relevant to what Israeli R&D semiconductor arena is going to basically face with. I'll be getting back on the India when we'll be discussing the geopolitical arena of the semiconductors on the local context. So this is basically our regional spotlight. India is basically having their own semiconductor mission systems, and this mission system or the mission program is again very robust, and basically having a lot of demand from within the software industry that they had in the southern part of the India, now raising their own concerns with some of the best bets within the timelines of their own semiconductor mission program, which they started about in 2025 and 2020 to 2025. This is basically an approachable area science policy derived, which is basically having a lot of scope within the sense of their own automotive industry aligned with semiconductor, the Tata Electronics, and two of the big fabs having their outsourced, one in Gujarat and one in Madras. What Pakistan is doing, I think a lot of stakeholders are sitting in this room, the house is full. Pakistan started its semiconductor activity. We're not going to go into details, back in slightly into some other shapes of semiconductors in early 85 to 90 with some of the universities. And then one of the leading companies enabling technologies, not going into those details, but very recently in 2021, this Pakistan National Semiconductor Plan, which was led by Dr. Naveed Shabani and Dr. Sajid Baloch, who is basically sitting here, the Director General NECOP, and I also took part as one of the authors of this National Semiconductor Plan with a team of another 20 authors who actually contributed from all different angles of the semiconductor design. And this was basically the spinning point, and this spinning point then translated into today's venture, which is Inspire, and this led to a complete derived policy of the semiconductor led by Ministry of IT, and we are going to hear a lot about it this morning. This is basically a presence of industry, which started about like in last 5 years, or even lesser than that. And good to see a lot of presence of these industries in this room this morning, but this is very encouraging that the chip design part in totality and various variant of chip design are now reflected as part of the business concern, the job creation and industry in Pakistan. So this is basically an approachable target. Within the next 5 years, we will discuss more on this one as part of the panels. About 7,200 engineers to be trained as part of this workforce development program, this PC1, which is supported by Planning Commission Pakistan, to launch the semiconductor mission of Pakistan in form of Inspire. So last 3 or 4 slides on some discussion questions from the academic lens, from the business and industry, and the policies and the governance, what exactly is happening all across the globe and particularly within our region to focus. So it is not just a theoretical kind of understanding towards the issues, but also some practical R&D which is already ongoing in various parts of the developed countries which are focusing on semiconductors, but also in our neighboring countries and also in the far east of Asia, for example in Malaysia, in Taiwan, in Korea, and also in Vietnam. So some of the concepts that basically being built across those lines are to revamping the whole computing arena. And this revamping of the computing part is again very important to discuss because of IoT and because of AI, semiconductor curricula, semiconductor research, semiconductor focus and attention is changing. And how are they changing is basically with this cone, and this part of the quantum coexistence is extremely important to understand because the quantum part of the subject is very much of a focus for more than moves and beyond CMOS part of the fabs, as well as for the designs and for various parts of the R&D that is basically ongoing across the world as part of their R&D budgets, whether they are industry or whether they are academic in nature like NSF and ESF. This is also extremely important to focus that what kind of science will be derived out of Mood 2.0 or beyond CMOS of the paradigm, which is again a matter of discussion for people who are actually doing the science part of this whole discussion. What is going to happen and how are we going to basically have the energy efficiency part derived, the transistor parts, a device, and a lot of different set of devices being made out of this context. some of the themes which are also rigorously coming up as part of the theoretical discussion within the semiconductor ecosystem, particularly the R&D sector, are the novel materials, the artificial materials, the 2Ds and the magazines, the silicides, some of the phase change materials. Also, the interconnect discussion is heavily based on the segregation of various design parts and the chiplets. I think this is very important for everybody who is working in the semiconductor science part, is to focus the new directions which is going to impact the theoretical foundations of the design thing, which immediately will be having a focus on the fabrication as well as manufacturing compatibility and capability of the systems. So there are extremely valid challenges all across, and I'll basically be just pointing out three because of the scarcity of time. We have to actually focus on the uniqueness of the designs. Whether do we need the uniqueness of the design as they are, as part of the IP or patency, or something which is more usable. That is one thing. That is basically a focus of those who are working not on the front end, not on the back end, but also on the design side with the downstream to upstream approach of the semiconductor science and technology. This is also important to put your ecology right within the semiconductor. So like I said, and like we basically just discussed, that this is overall a geopolitical matter rather than just pouring some money into doing good science or getting more business oriented out of that. It is also strategically important to devise your scheme of things with some of the compatibility and capability that we have, or we really want to regain out of this global system. And also, very, very important from our perspective is to see where things are actually pouring in future. What kind of things that we will be doing, which will be creating a niche for us. The validity of our designs. The compatibility of our designs. Do we really need to work on those things which are already being worked out, or do we need to actually have a novel thing or re-engineer those which are basically making a sense for the business and the market? This is also the key areas which needs to be focused. That one really needs to find the talent in the workforce area of the discussion very relevant to the all three dimensions of the ecosystem, the value chain. We really need to have those design experts or design run-of-the-mill engineers, or just to focus on those things, or perhaps making a little elbow more extended to the clean rooms, or perhaps to some of the laboratories which can act as a prototype developer. So indeed, this is also a kind of a tie between some of the concepts that have been worked out for other people, for other economies, for developing and developed nations, but where are we standing right now? We have to actually decide the fate of it, together with whatever we have achieved in our Pakistan Semiconductor National Plan, in parts with Inspire, and maybe going beyond and having a robust discussion on the issues that where Pakistan should lead in terms of design capability and beyond design capabilities. So leaving you with just a glimpse that this is going to be the future in total. This future is basically derived only by one particular segment, which is IoT, a huge market segment which requires all four of these capabilities: design part, the IP core thing, the front end, and the back end. And with which all four dimensions of the semiconductor are basically having one of the largest chunk of the market, which is predicted for 2030. Semiconductors are important, and we are really at the core of this discussion. Thank you so much.